a tiny pebble can end a run. Not because it's a big rock, because your wheels don't know how to deal with it. Wheel diameter decides whether the street kills your momentum or lets you flow right through it. And once you notice that, you start to realize that wheels aren't just about speed. They're about how energy flows through the system. I've been building and testing storm tracers for over a decade. And wheel choice is one of those things that looks simple on paper, but completely changes how a setup behaves in the real world. So let's talk about wheel diameter, the part of the system that touches the ground before anything else. There's a physics term that matters a lot here. It's called rolling resistance. In simple terms, rolling resistance is the energy you lose as your wheel deforms and rebounds while rolling over a surface. Wheels compress, asphalt compresses, and not all of that energy comes back. Some of this energy just as heat and vibration. That loss is actually really small, but on real streets, it adds real fast. And here is where diameter comes in. So you picture this. You are on a long downhill, nothing crazy steep, just long, just a steady descent. Same road, same line, same rider. First run, smaller wheels, harder compound. At the top, everything feels fine, but halfway down, you start to realize you're not actually accelerating anymore, and the road has that gritty asphalt texture. You're feeling all that vibration, and by the bottom of that long descent, you actually feel numb, and you're not actually as fast as you wanted or expected. Now you do the same hill, but with larger, bigger diameter wheels. Same push, same stance, but this time speed builds more smoothly. You're not fighting the surface as much. The wheels actually roll over the texture instead of falling into it. So that's a simplification of how rolling resistance works. Bigger wheels meet bumps at a shallower angle, so they lose less energy climbing over it. So less energy lost means more momentum conserved. And that's just not theory. You can actually feel that in your legs. Also there's momentum. Larger wheels, they work like heavier, bigger flywheels because they have mass, and that mass is rotating. They do take more effort to actually speed up because of that momentum and more mass, so they feel slower to accelerate, but once they're moving, they want to stay moving. Smaller wheels feel the opposite. They jump forward fast, snappy, and reactive, but they bleed speed quicker, especially on rough pavement. Neither is better. It's a personality choice. It's how you like to skate, where you like to skate. And for storm tracers, momentum isn't just about feel, it's about energy efficiency. And this is where wheel diameter becomes uniquely special for storm tracers. On normal inline skates, losing momentum just means you need to push more often. You just use your own legs. Maybe you get more tired, but that's it. On storm tracers, having a higher rolling resistance, losing momentum, means draining more energy from your battery. If your wheels are constantly losing energy to surface texture, cracks and micro bumps, the motors have to compensate. That means higher current draw, more heat, and of course less range. And since larger diameter wheels have a better rolling resistance, they resist less to movement, so they drain less energy. This also translates into smoother power delivery, better cruising efficiency, and more usable range on real streets. What's the point of range in a lab or a controlled track test, right? We ride on real streets. And of course, wheel diameter is just one part of the story. You also have wheel profile, and this plays a massive role too. But that's something we're gonna talk about in another video. And remember that wheel profile matters more than people think. Imagine weaving through a dense, city block at low speeds. Tight turn, quick corrections, little direction changes. Smaller diameter wheels, they feel really amazing in this example. You're closer to the ground, you spin easier, transitions feel better, transitions feel quicker. The skate feels like an extension of your own body. Now imagine the opposite, a fast open stretch. You're holding speed, carving long lines, letting the run breathe. This is where larger wheels shine. They smooth out the surface, feel calmer at speed, and makes the whole setup feel more planted and less twitchy. Same rider, same street, completely different rider experience. Now let's get Storm Tracer specific. If you're running hub motors, your minimum wheel size is already decided for you. Most hub motors can't physically be made to be smaller than 70 millimeters. And once you add the tire around the motor, it goes to around 90 millimeters. So in this example, choosing your wheel diameter isn't really a possibility. You are stuck with your minimum at 90 millimeter, you can't go that much higher. So it's actually constrained by motor architecture. And that affects how low you can go to the ground and how much clearance you have. How much the skate can actually lean, because hub motors are also wide. So you have a wide frame and you can't lean that much. So if you put a wide motor with the smaller wheel you can put in, smaller diameter wheel you can put in, you can't lean that much before your frame touches the ground. And that's dangerous. Once your steel metal frame touches the ground, suddenly control becomes really scarce. And this is very similar to motorcycle design. If you take a look at cruiser bike, like a Harley Davidson or something like that, you see that their motors are put very low to the ground and they're very wide because they're big motors. And those kind of cruisers can't lean as much. They're not meant for speed, they're meant for comfort. So they put the motor very low to the ground so the bike feels more stable. And when you turn it very aggressively, it's very easy to touch the ground. You can search videos about it. I've seen several cruisers sliding out of the corner because they touch the ground. And while sports bikes, like the Kawasaki Ninja, for example, they put the motor in a less wide position, like this, and they're made to be wide on top and very thin on the bottom, so they can lean very aggressively. So when we're designing Storm Tracers, we need to think about that as well. So if you are constrained about your motor size, putting it higher and bigger wheels will make you be able to lean more. But if you have a wide motor inside the wheel, you need to have a bigger diameter of the wheel to actually be able to lean more. Wheel diameter affects how aggressively you can lean into your curves. So as usual, when we're talking about building Storm Tracers, it's about trade-offs. You get better at something at some point and worse at some other. Wheel diameter shapes momentum retention, rolling resistance, ride smoothness, battery efficiency, stability at speed, agility, lean angle and clearance. There is no perfect number. When companies build a product, they will usually aim that product for mass adoption. So they like balance. Not too low, not too high. Something that feels stable, is efficient, and approachable for the majority of riders. But every Storm Tracer build setup, it's a compromise between competing priorities. And that's why wheel diameter isn't just another spec. It's a design philosophy decision. Next episode, we're going deeper. We're talking about wheel profile and grip, where control lives. It's actually literally where rubber meets the ground. We stormed the streets today. Until next time, trace the storm, Storm Tracers out.